Hello, GeeCON. Can you hear me? I think you can. All right, so it's great to be here. Actually, live, in-person conferences. Oh my God, it feels odd after 2 times of a break. So, welcome to the presentation titled Spectacles on Steroids. I will be honest with you and I will try to set the expectations straight. So this is not specifically a JVM presentation. And you can see AWS logo here, and this is not a specifically AWS presentation. It's a presentation about the project called OpenTelemetry, which is a very special project. It's an open source project. Actually, before we even start, if you could raise your hand, I can barely see you to be honest, but if you could raise your hand if you know anything about OpenTelemetry different than its name. So if you know anything about the OpenTelemetry, so please raise your hand. All right, only a few people. So you will learn the basics here. This will be no super technical, but the idea is to present you the project and to make sure you know why this project may be very important for you right now and hopefully in few years' time. And why so? Why is this project so interesting, so important? Yeah, I will tell you. All right, so my name is Sebastian Gębski. I'm a principal solution architect for a company called AWS, Amazon Web Services. You've probably heard about us a little bit. Here's my basic contact info if you want to stay in touch after the conference, if you want to ask a question or whatever. Here's a little agenda for today. And just a small hint, a URL and a code for the questions if you want to ask some questions during the presentation so I can answer them during the Q&A session. So the plan is very simple. I will describe you, or I will try to, let's say, make sure that we are on the very same page when it comes to what is observability. Then I will introduce the project called OpenTelemetry and how does it solve problems related to observability. Then we will talk about the actual implementation, or we call it actually a distribution. So a way of making OpenTelemetry more accessible for everyone. It's one of the ways, it's not the only way. So for instance, if you don't have anything about AWS, if you didn't work with AWS, but maybe you work with a different cloud vendor, it's perfectly fine. Because this presentation will still be applicable to you. And then, of course, I will show some screenshots because we don't have really time to set everything up from scratch. And we'll conclude with some additional materials for the people who would like to dive a little bit deeper on the topic. So we'll start with some very basic, very simple, and very obvious things, and we will fly through them like completely crazy. Two bad news, the worst and the absolutely worst. So the first one is that the distributed systems are complex. But the worst news is that pretty much every system is a distributed system. So here we have some visualizations of the architectures of few quite renowned companies. And of course, these are outdated. So at this point, these are far more complex. Each pretty much pixel on a picture represents some sort of a node, service, endpoint, application, and so on. And as you can see, they are very interconnected, they are very intercommunicated, they pretty much depend on each other. And of course, not every company, not every platform system starts like this, probably none do, but still at some point you get some level of complexity. And it doesn't mean that you need to embrace the idea of microservices to end up like this. No. You still have, processes, endpoints, different modules within your application. So it's very easy to get the complexity out of control. And there's one general rule when it comes to the presentations: always quote your boss. So I will quote my boss here. He says that Werner Vogel, the Amazon CEO, says that everything fails all the time. So if you could go back to the previous slide, you can imagine that all those nodes at some point fail. Things happen. What does it mean to fail? It doesn't have to fail utterly. It may be just increased latency. It may be an error that is handled or unhandled. And the issue is that, yes, those things can fail, and at some point we can predict or at least detect those failures. But the point is that they never fail in isolation. The failure cascades. It always cascades. So sometimes it can cascade so quickly, so rapidly, that it's actually very hard to find out where did the failure started. So when you have the half of this picture blinking red at some point, you don't really know when to react, what to deal with first. This is an issue. Of course, you can, stop the word and you can stop debugging the system. But the problem is that for the distributed systems, you actually can't do that. To be honest, I have some exception history from my past. In 2006, we've actually stopped the word for a corporate bank. And we've actually debugged the bank in a real time. But this was not something I would like to repeat. So anyway, moving forward. Fortunately, the problem with failures, errors, and predictability of the behavior is solved. And we have a whole branch of computer science, which is called observability, which deals with these problems on a daily basis. So just to give you the definition, you can see it on the screen, basically. So the observability is the ability to understand the internal state of the systems based on the information you can extract from this system. So it's making unknown known by using small deduction and, of course, by extracting meaningful data from the system. Observability, as I said, the definition, it doesn't come alone. Of course, it's associated with some additional terms like monitoring or visibility or telemetry. Here we have the definitions. Another crucial definition that you should be familiar with at this point is the telemetry, because this word will also pop up very frequently during this presentation. So the telemetry is the technical ability to actually get this internal information, to get the information that is generated within the components of your system, and to extract this information into some place where this information will be processed and analyzed. So that's the idea. You have a distributed system, you have many remote parts, moving parts, shifting parts, and you need to collect this information to analyze it all together. All right, so I said that this is already some sort of a discipline. And this discipline is quite well structured. There are some pillars or some elements of observability that are pretty much used by you on a daily basis, or at least I hope that you do this. So those three pillars that you see here, the most popular ones, are logs, metrics, and traces. Logs is quite straightforward. Logs are like since forever. In general, these are just events. The events that represent the historic information about what has happened within your system. No, not a big deal. Logs used to be unstructured. Right now, they are more structured. The idea is to be able to process them as quickly as possible, as efficiently as possible in huge volumes. Metrics are equally simple. Everyone knows what the metric is, right? You are measuring a state of your system. So a metric is, for instance, the error rate for a particular service. Or a metric can be a CPU utilization as a percentage. So that's the metric. The traces may not be that obvious for everyone, especially if you are just quite new to this business. So when it comes to tracing, the tracing is ability to actually trace some sort of a request, we call them transactions, across all the components of the distributed system which are being involved. So imagine that you have some edge application which is user-facing. Maybe it's a web application or a mobile application, and there's an interaction. The user would like to do something. Maybe, I don't know, extract something, get the list of offers from the marketplace or whatever. And it initiates the call, which may be just an HTTP request or a RESTful request or whatever. And then there are some databases involved, queues involved, maybe there are some other endpoints involved as well. There's authorization, authentication. So in general, it's one request, but under the hood, there may be 10 of different requests that altogether contribute to the final effect. So distributed tracing is building a real-time map of how this request propagates across your whole distributed system. And of course, you do this to understand the past behavior, what has happened. For instance, if you have a critical path within your request, which of course has a crucial role in determining how much time the request actually takes, you need to analyze this trace to understand which part took most or which part blocked the other parts. So that's what tracing is about. Of course, all those traces do not have to be analyzed separately. You can analyze a single trace to understand the root cause of an issue, but also you can merge all those traces all together to generate the service map. And the service map of the whole system is super useful because it really shows you the real-time dependencies. It can really help you to analyze the single points of failure. It can really help you decouple the components of your application, see the bottlenecks that are really happening in runtime. And of course, you can also group the traces to perform some more sophisticated analysis. Okay, so typically when we have an issue, when we have an error, maybe it's 3 a.m. and someone is calling, maybe the users are raging somewhere over the internet, you use those 3 pillars to understand what has happened. Because you, of course, cannot rewind back time. That's obvious, right? So you analyze those logs. Maybe you have to remotely SSH to all those machines to actually find out what has happened. You analyze the traces if you have them. And of course, the parts of the trace, they actually come from different machines. So they need to be correlated somehow. You analyze the metrics if you have them. Maybe some infrastructure metrics, maybe application-specific metrics, maybe even more business-related metrics. And you try to correlate all this information to find out what is the root cause of the issue so you can fix it and maybe go back to your bed. Okay, so this is not really new. I hope I've just reiterated stuff that you are already aware of and that you do on a daily basis. And to be honest, we have plenty of tools for that. And that's the diagram that shows you just the AWS tools. And my main message out of this diagram is that every other cloud provider has a very similar diagram. So in fact, we have plenty of tools available. And there are some other smaller cloud providers which provide more, I would say, focused tool, which do just one thing because they deal only with that. AWS is, I would say, more generic when it comes to that. So the problem is that if your platform gets quite big, quite complex, you may actually be deploying your applications on several different clouds. Or you may be using different databases which, for instance, provide you different metrics or different logs. Or I don't even mention about tracing. How could you, it actually sounds very, very complex to trace very complex business requests that goes across more than one database. Just to trace it completely and know what has happened within each of those. So it's a challenge when each of those vendors, AWS and other ones, for instance, introduces their own standards, their own formats. It's pretty much impossible. In fact, people use those tools. So here are some numbers. This is a slide for those who really like the big numbers. So how many operations actually happen within those observability-related services on AWS? And those numbers actually look quite unthinkable if you think about this for a moment. The only one which sounds more impressive or looks more impressive, it's probably IAM, so the one which is about authentication authorization. So these tools are already in place, these tools works, these tools are already used, but there was a need to build the common standard. There was a need to actually make switching the tools at various stages of observability life cycle, I would say, more easily. I don't know about you, but in my history, I was migrating from Zabbix to Nagios, from Nagios to Splunk, from Splunk to Riemann. Actually, Riemann was my favorite one. And then from Riemann to Prometheus. So each, I would say, era of computing has its favorite tools. And here, finally, there is an idea how to unify all those things, to introduce one project that will provide the common, that will actually bring in the common standard for not only the taxonomy, but also the formats, the protocols, and some sort of SDKs that you can use to instrument your applications in a very, very simple manner. So that was the idea behind the OpenTelemetry project. And this is actually not the first project that has tried to do this. Before we had Open Census, we had Open Tracing, There's actually OpenMetrics, I think, that is in parallel. So this one is supposed to replace at least OpenCensus and OpenMetrics. And OpenTelemetry as a project is already super popular. Because right now, according to the official statistics that you can check on CNCF website, CNCF stands for Cloud Native Computing Foundation. This is the second most popular project. And if you actually find out that the first one is Kubernetes, so it means that this one is second only to Kubernetes, that's really impressive, to be honest. Okay, so yeah, so what is OpenTelemetry? I said that it's a project. It's a set of standards that is supposed to be completely vendor agnostic. It's supposed to provide you a set of instrumentation libraries for all the languages that you can use to support manual or automatic instrumentation of your applications. It also provides you a standalone binary called collector, which is used to distribute the information that you collect, the telemetry information that you collect, across several different destinations. So it's not a single backend. It's not supposed to replace any vendor. That's not the case. This is not what OpenTelemetry is about. So what's inside this project? What's inside the standard? Of course, there is a cross-language specification that is then implemented on various platforms. So for instance, there's one definition of what is span, or what is trace, or what is measure, and so on. Inside, you have also tools to collect, transform, and export the telemetry data. That's what's inside the collector. Inside, you have the per-language SDKs. So for instance, there's an SDK for Java that you can use, but also for many other popular languages. And also, there are plenty of other automatic instrumentation and country packages for various popular frameworks, libraries, and other tools that you use on a daily basis. So you can minimize the amount of work that you have to do to instrument your applications. Some key concepts that are being used within those three pillars of observability I've mentioned before. So for the pillar of tracing, so when you are trying to trace the request across the whole distributed systems, you have traces. Trace is just this request that goes across the whole system. Span is an element of this request that happens across one single layer. So for instance, it's a part that happens within a single service that is being called on the way. Context is everything that uniquely describes this trace across the whole distributed system. So this is the part of official nomenclature, official dictionary of the project. For metrics, you have counters, which are values that are being summed over time. You have measures, which is something you can aggregate within a given period of time. I think it's quite common definition. And there's an observer. So this is an entity that is able to capture the current set of values, but for a given moment of time, for the whole system or for a whole set of resources being monitored. Log, the definition of log is very simple. It's just an event, historical event that has been recorded. And what is very interesting, log, it can be linked to the span. So you can correlate how the request is being traced across the whole system with particular events that have been recorded in logs. Three other interesting definitions. There is baggage, so you can record your own custom information for your own sake when you are trying to correlate what's happening, for instance, in your business with what is happening within the trace. So you can later aggregate by the information that you have in a baggage, for instance. Or you can connect the parts of the trace that are not technically connected, but are connected because of some other dependencies outside of the system, which may be very interesting. There's the collector. So the collector is this standalone process that it receives the telemetry information and it pushes you towards different destinations. It can be more than one destination. And finally, the final term or final concept, which is very important, is distribution. So distribution is pretty much a bundled set of OpenTelemetry libraries and SDKs that is being distributed, so you can use it in your applications, And the idea is that there may be many distributions, like distributions of Linux. And the idea is that, for instance, every vendor can create his distribution to enrich OpenTelemetry with libraries specific for his offer. So for instance, imagine that there is AWS, and AWS already has an application for tracing. It's called X-Ray, and it has a fancy user interface and so on. So what AWS has done, it has created a library which makes X-Ray a destination for OpenTelemetry. Other vendors will not care. AWS has specifically created it for people who are interested in AWS. And there are other enhancements which can be made. I believe that pretty much every cloud vendor has created something like this. It has created a separate distribution. So it's a project, right? And the project have their lifetime, have their lifespan. There's some activity that happens within the project. How mature is this project? So what is the exact stage? Where are we? So to be honest, we are not there yet. I mean, out of all those pillars, only tracing is considered fully stable, GA, I would say, generally available, and it has happened last year. So SDK is stable, API is stable, protocol is stable. For metrics, we are almost there. It was supposed to be finalized last year, but it didn't happen. And for logging, it's supposed to be finalized before the end of 2022. So there are plenty of people who work on this in parallel from all the organizations, because they are all in. They are all very, very heavily involved. All the cloud providers are, for instance, very heavily involved. It's a community project. And the things are developing very rapidly. So we are here at the JVM Fall Conference. So you are probably interested, how is the Java world supported here? So here we see just the list of few popular frameworks and libraries that are already supported. And it's not even 1/5 of the whole list. So if you want to see the whole list, you can check the URL, which is at the bottom. So all of these have already some instrumentation for OpenTelemetry. And this instrumentation is very specific to the concepts used by those libraries and frameworks. So for instance, imagine that you are building a web application in Play or in Spring. Then your key conceptual entity is, for instance, request. So here, using the automatic instrumentation, you don't have to instrument every request. It's done by the automatic instrumentation, which is already created for you. For akka, it works in a different way. For actors, for instance, you're just dealing with the message. The message, it has its own instrumentation, and again, you don't have to create it from scratch. You can just enrich it whenever you need it, but you can use the instrumentation that is already provided for you. And to be honest, just one hint. There are so many of those projects that if you are actually considering entering the open source world, I mean contributing to a project, then it's actually a good idea to look at those instrumentation libraries for your favorite library or framework. It may be a very nice way to not only getting additional skills and experience, but also for doing something good to the ecosystem that you support and use on the daily basis. So it's just a small hint. So the general architecture of OpenTelemetry is super simple. So you have your one application, you have those libraries and SDKs that are specific for this particular library or framework. Then you have the collector that you have somehow to deploy. And this library, this SDK, sends the open tracing information, OpenTelemetry information to the collector. And then you configure the collector to send this information further to the destinations you care about. The good news is that there are already so many vendors that do support this that you probably will not have any problem with using the service that you already use on a daily basis. But after switching to OpenTelemetry or OLTP as a protocol which is used for communication. So I've mentioned the distributions. One of the distributions is AWS specific. It was created by Amazon. The idea is, I already described the idea, so I will not cover it again. One of the biggest benefits is that, for instance, when it comes to security, you can use Amazon-provided authentication and authorization. So the actual setup of OpenTelemetry, if you're using open source tools, is super trivial. Yeah, so for instance, I will just mention the last point here. Here are the example services that are already present on Amazon that you can use to integrate your OpenTelemetry in your applications if you decide to use this AWS distribution for OpenTelemetry, which is also an open source project, by the way. So here's the list of all the components, and of course I will not read through them. The orange ones are the ones who have been added to the list. So these are the AWS specific ones. So for instance, some of those additions automatically extract metrics from the specific AWS services. So imagine that you deployed your container on ECS. You don't have to set up the metrics manually. It will automatically extract those ECS specific metrics and send them to the destination of your choice. All right, great. So this is a sample observability architecture based on OpenTelemetry and open source products, which would run specifically on AWS. So you have an application which is running in Kubernetes. There is an OpenTelemetry deployed on a Kubernetes cluster, for instance, as a sidecar. Then the information is being forwarded, the metrics are being forwarded to a Prometheus server, or even directly to manage Prometheus. You have Grafana for visualizing this stuff, and then you can set up some additional alarms, which, for instance, will use Lambda and to notify you about the anomalies that have happened. For those of you who don't know what is Prometheus, Prometheus is a super popular project. They call it monitoring and alerting toolkit. I would say that it's more like a powerful engine that is able to collect time series information, typically the one optimized for telemetry, and make you able to query this information using a dedicated language called PromSQL. And it's very easy to integrate this engine with visualization software of your choice. So in case of AWS, you can have it in the managed version. So you don't really have to care about the configuration. And it works in a very simple way. So you can forward the information from your application via the OpenTelemetry to Prometheus. And then you can, for instance, use Grafana to query those metrics and visualize the effects. And you can have set it up pretty much in a few hours. Grafana, I hope that you are all aware of what it is. It's just a visualization software that is also optimized, or I would say dedicated to working with the time series data, but not only. It's open source, it's super flexible, and there is also a managed version, so you can set it up very, very quickly. So when it comes to the container application, if you want to instrument your own application, you can do this in a very simple way. You deploy your application in a container using ECS or EKS. You deploy the collector, so the binary component I've already mentioned, as a sidecar, and you just configure it using a set of the configuration files that are pre-created for you with the destinations. And in this case, one of the destinations for traces is X-ray, the other destination is manage Prometheus. And this is pretty much everything you have to do. So this is the infrastructure as code definition for the sidecar container. This is the real production definition, made a little bit shorter just for the sake of clarity. So the only things here that are really, I would say, OpenTelemetry specific are, there is a container image, which is already created for you, so you don't have to build it from scratch. There's a command here. This command is just the config file, which represents the scenario that you are actually trying to implement. So in this case, it's ECS AMP X-ray. So ECS is a source because I'm running it in a container on ECS. AMP stands for Manage Prometheus. So I want to forward the information to Prometheus. X-ray stands for X-ray. This is the tracing visualization software. So all I had to do is to specify this image, the command, and 2 environment variables. And those environment variables tell me where is my, what is this endpoint of my Prometheus workspace. So that's everything I have to do. Of course, when it comes to the application, it really depends on which framework you're using. So I wanted to show you something which is not framework specific. So that's the generic instrumentation in Java. So of course, you need to have some initialization code. This is the example. I'm not going to, let's say, go line by line, but the main idea here that you have to specify, for instance, how the identifiers of your spans are generated. Because, of course, you need to correlate those spans across all the components of your distributed system. So you need to tell OpenTelemetry who and how generates the identifiers. So that's one of the things we do here. You can also specify here the protocol. So in this case, it's OTLP. So this is this OpenTelemetry exchange protocol, which is here running over gRPC. It's OTLP, gRPC, span exporter that uses this gRPC. All right, so how do you play with those? This is the manual instrumentation. So this is something that you do if the automatic instrumentation is not enough for you. So what I'm doing here is, of course, the first thing is to create a tracer. So the tracer is like a OpenTelemetry client that I use later to do all the things with OpenTelemetry. So here I get the tracer, and then I can generate the span in my code manually. And I can make this span current ones, because you know the important information is nesting. So I need to make the current one to make another one which is a child of this current one. So I have to manually nest them. And this implementation or this language-specific construct, they really depend on the language. So for instance, if you have a language with a scope-oriented structures, like with in Python, it looks a little bit different. But the general idea is the same because this is fully compatible. So in this case, what I'm doing here is I'm making a span, I'm running some code within a span, and of course, finally, I'm finishing or concluding this span just to make sure that it really represents this scope of code or this scope of functionality, even if there is an exception cast on the way. What else I can do? I can set attributes, so I can enrich the span with some custom information that later can be used for filtering or just to understand a little bit better the context of what happened. I can also add some events. I can correlate the spans, even if they are not nested. It's also possible. I can do this. Another thing which I can do is I can also set the state of a span. So even if I've somehow handled an exception or another kind of error, I can set the state of the span as an error. So later, this can be also filtered out during the analysis when the incident happens. So this is also something I can do. These all API calls are based on the SDK for Java. These are just examples, simple examples of how you can manually instrument your application. All right, so this was for the container-based applications, but what about Lambdas? What about serverless? You don't run a sidecar when your code is in Lambda, right? So there's fortunately also a way to do this. So there's a layer, a Lambda layer, then you can attach to your Lambda function. And this layer is pretty much a set of bundled code libraries that is automatically used by your Lambda, of course, if, let's say, initialized properly. And this works in exactly the same way the sidecar does. So what is happening, we have here this OTLP buffer. And this OTLP buffer, it collects the information from your instrumentation, manual or automatic. It bundles it, and then it uses this extension, Lambda extension, to actually send this buffered information into the configured destinations. So it's pretty much the same kind of architecture. It's done for you automatically. So the whole idea of using the distro was for the container-based application to deploy it in a simple manner, And for Lambda to also deploy it in a simple manner just by adding the layer. And this is how you add this layer. Again, it's infrastructure as code definition. So if you are using CDK, this is how you would do this. The Lambda layer is already created for you. So this one is actually in Python. So everything you specify is the language, architecture, in this case is IRM. And then you just mention this layer, and you configure one environment variable, which you can see at the very bottom. And this is everything you have to do to actually configure this additional layer for your Lambda functions. So here's a simple application I've deployed. And what this does is actually there is some code running in containers. This code calls some Lambda functions. The code keeps its state in the relational database in Postgres. And there's also a Dynamo non-SQL database, which is accessed only by Lambda. So I've created some application, I've created some code, I've deployed this. So the left part is my application stack, and the right part is my telemetry stack. So I configured all of those applications or all of those components at the left to send the telemetry to the observability stack on the right. I will show you some screenshots how did the effect look like. So this is the service map which was generated in X-ray. So it corresponds to the image you've seen just a moment before. But this is built in real time on the actual calls. So again, we have some client which has called my application in a container. This application has directly accessed the SQL database and the Lambdas, which in the end called some DynamoDB tables. This is how the span was visualized. So it all has started with Octane API at the very top. And then I've created some custom spans, because span doesn't have even to represent the function in my Java code. It can be just a part of this function. And then I called Lambda. And here at the bottom, you can see also the rest of this trace, which was in a different machine, which was in the Lambda function, because this is the part of the distributed system, right? So you see here that the actual Lambda, it took only 43 milliseconds, but invoking it actually took 195. So there's a significant overhead, and right now we see it. So right now we see that actually something about the initialization, getting the connection or whatever else, it has taken a significant amount of time. So we see that there may be some problem here. When it comes to the Lambda handler, 41 milliseconds were just this DynamoDB poll. So the only problem that may happen here when it comes to efficiency may be on the DynamoDB side. That's another example of such a span of the distributed trace. In this one, there's actually a call to the SQL database. And it was super simple to instrument because it was just, I think it was Postgres. But everything I had to do is I had to add the library, the JDBC library, companion library, and I didn't even have to configure anything. So you can see right now here this call on the screen. It's Octane Aurora DB, and if you check its metadata, you can even see the query which was actually running there. So we have the exact information of what has happened, where it has happened, in what order it has happened, and what was the effect, if there was any kind of error. And of course, you can also check the metadata associated if this is something that is crucial at this moment. Oh, here's the example when something has finished with an exception. It's painted in beautiful red. You can see the error message. You can also see the stack trace. Here's the part of the screen that you can actually use to work with traces. So you don't have to go trace by trace manually. But for instance, at the very bottom of the screen, you have the time span distribution. So for instance, let's assume that you have the problem of the long tail. So in general, your requests are being served very, very quickly. But there are some who actually take a lot of time. And actually, you can see it here. At the bottom right part of the screen, there are some requests which take more than 2.5 seconds. So what you can do here, you can filter your traces by, let's say, this period of time span and analyze only those requests that take more than 2.5 seconds. All right, so we've switched from white to black. Why so? Because this is exactly the same information you've seen a moment ago, but in a completely different destination. So a moment ago, I showed you how it looks like in X-ray, and this is Grafana. So I've used the same information. I didn't have to add any code. I've just forwarded the same information, the information in the OpenTelemetry standard, and I forwarded it to Prometheus and accesses it using Grafana. So if you are familiar with Grafana, you're probably familiar with this screen. So again, you can see here the traces, and you can see here the span analysis of this particular trace. Grafana is also able to create the map. And there's actually something which is very interesting here that I wanted to show you, and it's here. So here are the details, the metadata information for the request. And at the very bottom, you can see default device. And this is exactly actually the custom information I've added myself. So if, for instance, in your system, you need to debug the one single merchant in the marketplace, which consistently has some problems, or particular client, or maybe transactions in a given currency. So if someone from the business or from support comes to you and tells you that there is a problem, but this problem is only for those conditions, for those circumstances, you can easily add this information to the traces and then later use this when troubleshooting and analyzing what's actually could be happening. Actually, I was telling you a lot about the traces and spans, but metrics are also present. So these are the OpenTelemetry metrics visible in Grafana. You can see here the yellow lines and the green lines because I was making a deployment. And of course, this was the floating deployment. So before the old container was killed, the new one was, it has to be confirmed that it's healthy, and so on, so on, so on. And actually, those metrics that you can see here, ECS task memory utilized and ECS task CPU utilized. Again, these are automatically extracted. So you don't have to do anything about this, because this is what those vendors add in their own distributions. So you don't have to do this by yourself. So for instance, here we have the list. If I've decided to redeploy my application into EKS, so managed Kubernetes, there would be a different set of metrics. And I don't even have to know about this until I have to pick. So I don't even have to configure this. These are just present. Okay, cool. So here's a bunch of links that you may be interested in. There is a good book on telemetry in general. This book is not really dedicated to OpenTelemetry. It's more about telemetry as the whole topic. So you can read about more all aspects of telemetry, all the pillars of telemetry there. Actually, they mention one more, because they mentioned the fourth one. They call SIEM a separate pillar of telemetry. So we can read about this and make your own mind whether it's a separate pillar or not. So it's a good book. Make sure you to check it out. Of course, there is the website of OpenTelemetry, and there you can find all of those libraries and SDKs for all languages and frameworks. So if you are, like I said, if you are interested in contributing to open source, it may be a good idea to check this out. There's a separate web page for ADOT, so for this AWS distro for telemetry. And there's some good examples there. So if you, for instance, want to try it out on your own, just to compare it, how it compares to the telemetry, to the observability stack that you already have, it's a good idea, because you can do it pretty much for free. The good point about all of those components is that they are serverless, to be honest. So if you are just using this for experimentation, you will pretty much pay nothing. There's the full workshop. This is the link number 6. And this full workshop it guides you step by step how to set it up. So how to deploy this sidecar in a way that is fault tolerant, resilient, just to make sure that you don't have to configure too much stuff. All right, thank you very much. Again, it was really nice to be here. I hope that this project will be interesting for you, because this is supposed to be some sort of, maybe not a replacement, but unifying factor for all the observability-related and telemetry-related tools that will be present in the space in the next few years. So even if you do not use this explicitly, you will probably use it by using some libraries which embrace OpenTelemetry under the hood. So thank you very much. We can actually, I think, switch to the questions in Slido. If I manage to get it on the main screen, it is. Give me a second. Yeah, I still can't see it. What the? Oh yeah, it's better. Oh, come on. All right, so it looks very complicated though. Could you compare benefits to Datadog, for example? Talking about Java apps, thanks. It's not an equivalent of a Datadog. Datadog is one of the destinations. So in general, the whole idea is that OpenTelemetry replaces the end-to-end observability solution. So it means that it gives you the component to instrument your application in a generic way. So if you at some point decide to switch from Datadog to New Relic, or if you decide to use some open source tools, you still use the same instrumentation, which is a generic instrumentation. And you can switch from Datadog to another destination just by changing the configuration. So that's how it's supposed to work. That's what the vendors of, for instance, Datadog, New Relic, or AWS, or whatever, that's what they have to accommodate to. So this is the whole idea. The Datadog can be just a backend which visualize the data, which maybe gives you some unique opportunity to, for instance, process the data in some unique way. Maybe. But they work on the same data. So the way you collect the data, the way you structure the data, this is given by OpenTelemetry. And then what this backend, like Datadog, does, it's specific to Datadog. So that's basically the shortest comparison. Is it really complex? I would say that I wanted to present you the whole project, but in general, everything you have to do when you instrument your applications is those code samples that you've seen. So, and the majority of instrumentation is being done automatically. So you don't even have to declare those spans manually on your own. Is OpenTelemetry good only for request response applications or also for batch processing? It's a good question. Even if you pay attention to this nomenclature I've used before, that we have those traces, and the traces actually in the word of OpenTelemetry are called transactions, and those applications that initiate those transactions are called services. So it may give you a hint that this is actually probably some OLTP rather than batch-oriented, but in fact it really depends. Because for instance, for batch processing, I can still imagine that you do some instrumentation and you create those spans just to reflect the internal structure of your batch. It's probably possible, but it's much harder if you, for instance, use some declarative languages, even SQL style, because a single SQL command can actually process terabytes of data. And it's really hard to inject the code within this command to actually find out which part of this data is more troublesome or has caused your processing to jump out of the index or something like that. So I would say that it really depends. But for some, especially declarative languages, I can hardly imagine. Where you can find the slides from your presentation? Well, at this point, only on my computer. But of course, I will be in touch with the organizers just to make sure that we can somehow share them on, I don't know, slide deck or something like this, that this can be easily done. And also probably the code samples or even some videos, because you've seen just screenshots just to save time. But it's good to see how it works step by step, especially how it correlates to the actual activity in the end user application. Does OpenTelemetry AWS distribution use embedded metrics format EMF to emit the information to CloudWatch? The idea is that maybe I've gave you the wrong impression. The way OpenTelemetry does and the collector does, it doesn't strictly rely on OLTP protocol. No, it can actually use different protocols. So for instance, Jaeger has its own protocol, and CloudWatch can use its own protocol, and other tools can use its own protocols. So the idea is that this collector is able to use the most popular protocols to communicate with those tools as well. So this single protocol, which was created for OpenTelemetry, doesn't have to be the exclusive one, the only one which is used. So typically vendors enrich the components with the protocols they already know. But the idea is to have the same entities. So to represent the same concepts, like span, trace, log, event, baggage, and so on. The idea is that it has to be compatible with those concepts. All right. This was the last question. So thank you very much. If you have any questions, I will be around still for some time. So feel free, ask questions, or use the contact information I had on my slide to contact me after the conference. Thank you very much.